So the question here says that we have 5 ml of 8 normal HNO3, 4.8 ml of 5 normal HCl, and a certain volume of 17 molar H2SO4, which is mixed and made up to 2 liter. Matlab we are diluting it. From here we are taking a sample of 30 milliliter, which will neutralize exactly 42.9 milliliter of Na2CO3, and whose strength is given to be 0.1 gram of Na2CO3.10H2O in 10 ml of water. Indirectly they have given you the strength. From this strength you can find out what is the normality of Na2CO3. Once you know what is the normality of Na2CO3, you know what is the number of equivalents of Na2CO3, and that will be the number of equivalents of acids in 30 ml. From there you can scale it to find the number of equivalents in 2 liters of acid mixture, and the number of equivalents there will be equal to the number of equivalents of the acid mixtures that you have mixed. Fair enough flow that we have to follow. Before that, let's revise a few concepts, small concepts. I hope you know the concept of milli-equivalents. It is whatever is the mass of substance upon its equivalent weight. And to find out equivalent weight, you just need to take its molecular mass or molecular weight and divide it by its n factor. The second thing that you should know, in general, you depict strength in terms of grams per liter. And if you know the strength, you can find out its normality, grams per liter divided by whatever is its equivalent weight. See, effectively this becomes G upon E divided by L, which is equal to number of equivalents per liter of the solution. Third thing that you should know, the number of milli equivalents is equal to whatever is the volume in cc or milliliter into whatever is its normality. That will give you the number of milli equivalents. This formula directly follows from the formula above. Now given that, let's try to analyze. Let's start with Na2CO3. The equivalent weight of Na2CO3 dot 10H2O will be equal to its molecular mass, which is 286 grams, divided by its n factor, which is equal to 2. And this comes out to be 143 grams. That's the equivalent weight. What you are also given is the strength of Na2CO3. The strength of Na2CO3, if you see, is 0.1 grams in 10 milliliter. So in 1 liter you will have 10 grams. You will have 10 grams in 1000 milliliter. So its strength is 10 grams per liter. So once you know the strength of Na2CO3, you know what is the normality of Na2CO3. Normality will be 10 upon 143. So this Na2CO3 solution is 10 upon 143 normal. And you have taken a 42.9 milliliter of Na2CO3, right? You have taken 42.9 milliliter of Na2CO3 solution. So the milli equivalence of Na2CO3 is equal to 42.9 into 10 upon 143. And this must be equal to milli equivalents of 30 ml of acid mixture, because this acid mixture actually kind of neutralizes it completely, exactly neutralizes it. So this will be equal to 42.9 into 10 upon 143. This must be equal to 30 milliliter into whatever is the normality of the acid mixture. Look closely, this and this will get done by 3. So the normality of the acid mixture is 0.1 normal. So you know the normality of the acid mixture. But you know that 30 ml was taken from a box of 2 liter, right? That 30 ml of acid mixture was taken out from a box of 2 liters. So this is called sampling. In sampling, the concentration of the solution does not change, but number of equivalents will change. So what does that tell me? So the concentration of this 2 liter solution is also 0.1 normal. So what is the total milli equivalents of acid that you had, which is 2000 into 0.1. So you had 200 milli equivalent of acid in this 2 liter mixture. But how was this 2 liter arrived at? This 2 liter mixture was made from 5 ml of 8 normal HNO3 plus 4.8 ml of 5 normal HCl plus X ml of 34 normal H2SO4. See, we were given 17 17 molar H2SO4. The N factor of H2SO4 is 2, so its normality will be 34 normal. So you had mixed these together and then you had added water to it to make it up to 2 liters. Now this process here is called dilution. In dilution, the concentration will change, but the number of milliequivalents will remain same. So whatever is the number of milliequivalents you had in 2 liters will be same that you had added up initially. So this 200 must be equal to 5 into 8 plus 4.8 into 5 plus x into 34. It's a matter of solving it from here. 200 is equal to 48 plus 24 plus 34x. Fair enough? 48 plus 24 is 72. So 200 minus 72 will be 128, which is equal to 34x. And the value of x will be equal to 128 upon 34 milliliters. 40. Oh, 5 8s are 40. That's my mistake. Sorry. We'll do a little bit of calculation change. 5 8s are 40 plus 20 64. 200 minus 64 is 136. So it will be 136 divided by 34. It will cancel it and 4 times. So x is 4 milliliter. So you had added 4 milliliter of 17 molar H2SO4 to that mixture. That's your first part of the question. First part of it. The second part asks you what is the amount in grams of sulfate ions in the solution. What is the amount of in grams of the sulfate ion solution? How much sulfate ion is present in this? So you know you have 4 milliliter of 17 molar H2SO4. So you know the number of moles of H2SO4, right? The number of millimoles of H2SO4 is 4 into 17, which is 68 millimoles, right? And 1 millimole of H2SO4 contains 1 millimole of sulfate ion. So what is the number of millimoles of sulfate ion? Millimoles of sulfate ion is also equal to 68, right? So the mass of sulfate ion will be equal to 96 into 68 divided by 1000 grams, where 96 is the molar mass of sulfate ion, right? Sulfate is 32 plus 4 atoms of oxygen, which is equal to 96 grams. That's the mass of 1 mole of sulfate ion. You can calculate this to get the mass of sulfate ion.